In this video we will continue on decision tree classifier. So, we saw that decision tree is developed in 1996 as a ID3 algorithm and lot of variants of them is used in the current modern tools. Let us look at what is ID3 algorithm that actually to answer two things, which node to choose as root node and where to stop. Okay. This is a very key questions we have to answer in the decision tree. So, let us see with this particular table you have attendance, midterm marks, final marks is greater than 70. You have seen this table multiple times. Which node to choose as the root node and where to stop. I am not going to explain solving decision tree in this particular table, but I am going to explain the mathematics begin, which node to choose and where to stop, and you can apply that formulas on this. It involves only two things, one is entropy and information gain. You all might know what is entropy in your field. Entropy is defined differently in different fields, like electrical is different, mechanical is different. But let us see it is to measure the uncertainty in the data. Okay. That is the example, let us use it here in computer science. Entropy of X is particular entropy of particular S is the complete set, complete data is property of S. So, that is entropy formula, it's simple, like let us y to simple. So, entropy of S is this is a formula minus pi into log pi. This I is number of classes, if it is binary it is yes or no classes, it is 2. If it is 4 classes to classify in decision tree it will be 4 something like that. So, probability of pi number classes. So, pi is probability of yes and p2 is probability of no. So, if I apply this to 2 class problem like yes or no, probability of yes log probability of yes and probability of no log probability of no, that is exactly given in this equation. The log 2 check this base, so it is very important, there are 2 classes, that is why we use log 2 base, 2 base. Okay. If you compute this with log 2 base value for the previous table previous table, let us see how many yes and how many no. 1, 2, 3, 4, 5 out of 7. So, 5 out of 7 is 0.71 and 2 out of 7 is 0.29. If you compute that in this particular log 2 value log 2 base, then it is the value 0.87. What does this 0.87 means? Now it says entropy, and what is this particular 0.87 means? Should I consider this as a good or bad? What does this 0.87 means? Let us understand what is entropy with the probability, a simple diagram. Okay. So, this diagram is not clear. Okay. This is the probability value, this is the entropy. Okay, entropy of yes. So, this is 0.5, this is 1 and this is 0 and this is 0.5 and 0, something like that. Okay. So, probability value 0 or 1, the entropy will be 0, the probability value of 0 or 1, entropy will be minimum for 2 class classification problem I am talking about. Entropy will be very minimum, that is 0 entropy. For probability value is equal to 1, say probability value is 0.5, the entropy will be maximum. So, let us try to understand what is entropy measures from the probability value. So, this is maximum. So, what it tells is in the previous example consider I have 30 students passing the exams and 30 students failing the exam. So, probability of passing the exam, probability of yes, that is a pass the exam is 30 by 60 total students. So, 1 by 2. So, 0.5, right. Probability of passing the exam is 0.5, which means opposite, the probability of failing also 0.5. If there are 60 students, half of them can be passed, some of them certainty is not there, uncertainty, like it's like equal value. If you pick any student, it can be either pass or fail. So, always 40% probability. So, the entropy is high. Okay. Consider I have probability of I have this so same 60 students, I have say 59 students pass and only one student fail, right. So, which means probability of yes is 59 divided by 60, it is almost 1, you know, point you know, 0.9 something, 0.94 something like that maybe. So, it is almost 1. If probability of S is almost 1, the entropy will be very minimum. Okay. So, that tells the uncertainty to classifying this thing is very low. So, if you pick that value, any student from this class, you can say pass, because 59 out of 60 will pass, only one time it will fail. But so that is why the probability, if it is a equal amount of both yes and no, black and white, or the two classes, entropy will be high. If the number is less, like it is only black or only white, the entropy will be low. Our aim in a decision tree classifier is to bring that entropy equal to low, not high, because I want to make a decision of one leaf to be this student will attend a class, this all students here will not attend the class. So, my aim here in decision tree is to bring that entropy value to as minimum as possible, that is it. That is a basic concept of what is decision tree works of. So, in a previous example, if you look at that, see 5 by 7, 2 by 7, it is almost you know it is 5 by 7 and 2 by 7, it is almost what to say, it's not like a 3 by 7 or something, but 5 by 7 is also not exactly 6 by 7 by 7. So, if you say 0.71, 0.6, 0.7, if you plot that value, so 0.6, 0.6, 0.7, if you plot this value, okay, I am sorry, it goes something like that, 0.9, so it will be 0.87, something we have computed in the entropy. That is exactly the formula we computed in a 2 class classification problem. That is entropy. So, which node to choose? Now, you can understand which node to choose. You have to apply entropy on all classes. So, there are 7 classes, entropy is 0.87, and you have to select one of the feature and create one of the applications, say the attendance is high. If you put the attendance equal to high, what happens to the entropy? If information gain entropy is reducing or not. How do you know the entropy value is reducing or not? It can be computed by the information gain. Let us look at what is information gain. What happens is it takes the entropy of the complete set, right, without making any decision. They are all root. So, entropy of complete set is 0.87. I am not taking any decision, just given a particular student, whether the student will pass or not, I just make a decision out of it. So, I will be true about 71% of time, that is 0.7 probability, but we want to better classify, right. So, this is a given set entropy divided by, if I want to divide this, if you want to divide this, make a decision tree out of one of the feature, let us say I will select one feature. The feature I selected is midterm marks, right. So, I consider the midterm mark as a node. Okay, you have to select all other features and select different values for features. Let us take midterm marks as the node, and if I consider midterm marks as the node, and what will happen is, so midterm mark as a node. So, I have selected one value. So, let us see. If I select a midterm marks as a node, we need to compute what are the classification you can make from the midterm marks. So, my root node, consider my root node is midterm marks. Now, you need to make a decision whether you want 2 trees, 2 branches out of it, or 3 branches out of it, like 2 child or 3 child. I make a 2 child. One is say greater than 50, sorry, less than 50, and one is greater than 50. So, I make a decision here, right. So, how this number comes up, it is also the mission, like you have to compute different numbers, or you can make it to different categories, or that is all about how do you start with that. So, let us say I will take a midterm marks the root node and I computed only 2 decisions less than 50 and more than 50. Okay. Now, there are 2 values to be there, that is a values v, so one values of the particular a that midterm marks. Now, it is 2, only 2, let us consider there exist 2 different classification in this particular midterm marks. I am not talking in a mathematical term to explain this value, because my idea is to understand what is information gain, what is entropy in a general sense. If you want again I am telling, if you want to really know mathematics begin all this, want to use exact mathematics terms or the values, please go ahead and read in the internet. My idea, this course is for prerequisite none, which means I want to keep the maths as low as possible, but explain the core concept behind these algorithms. That is why I keep it as easy as possible. But if you are interested, get motivated by this videos, I request you to go and check in internet and read more. So, let us consider the midterm marks has 2 values. I want to make 2 decisions less than 50, more than 50, only 2 values. So, that is exactly 2 values, which means what happens here is entropy of S, this okay, this is basically less than 50 marks. There are 5 students who got less than 50 marks, there are say more than 50 marks 5 students, the 2 students out of 7 got less than 50 marks. Let us look at the table again once. Okay. In a midterm mark, yeah, that is exactly here. There are 2 students who got less than 50 marks and all other students, 5 students who got more than 50 marks, right. So, let us classify it. So, let us see all the 2 students who got less than marks is no, and other students have passed the exam. So, let us come back here. When you come back here, there are 5 students out of 7 who got less than get 50 marks. That is exactly this class. This is what 5 by 7 here. Complete set, how many people are particular value, the decision you are making 5 by 7, entropy of getting more than 50. So, we saw that probability of students who are passing more than 50 is 1. If the probability of 1, which means entropy equals to 0, similarly probability of less than 50 we are getting probability of passing the exam is 0, which also equal to 1, like it is also 0, okay, both are 0. If it is 0, this value will be 0, complete 0. So, the entropy gain is the current entropy, that is 0.87. So, there is no information loss. So, maximum gain, you select a node which has the highest gain as a root node. Okay. So, some other if you pick any other node or any other decision, maybe instead of 50 I pick a 40, you might have a different value, then that value will be less gain. So, you have to pick a root node which gives you the maximum gain, and the gain will be computed by the current set. This is currently a root node, maybe next step it is not a root node, maybe next step some other decision can be taken. So, then the decision you want to make, then you compute this information gain formula, then you compute it. So, for example, in this particular time if less than 50 you can simply draw that is it, it is simple. This decision tree of this particular given table is very simple, yes or no, that is only one root node. Try this decision tree with much complexity, you create your own data with the 30 students attendance, 30 students midterm marks and 30 students engagement in the class, 30 students are submitting assignment in time and their interaction with the Moodle or something like that. You create a big table and also why, and compute and see how this decision tree is made. Okay, that is the idea. Let us see that is what is a root node, and you want to know when to start is no more conditions to make. Suppose you have seen all the conditions, all decision has been made, and also all the options belong to one group. Consider you already achieved everything to be probability 1 or 0. Okay, all the students will be in here 0, yes or only no. If you assume that particular reach that level, you have to stop the decision tree. So, you have seen decision tree, right. What are the drawbacks of decision tree learning? List down 2 points. Please list it down. After listing it down, resume the video to continue. So, the complexity increases if number of decision increases. Okay. It looks very easy if you have say 5 levels or 10 decisions to make, the tree looks good, nice. If you have say very complex problem, have the 15 features 20 features, and each has a different values, categorical, more category, not just 2 decisions, more decisions to make, the tree will be very complex to look. Even it is visually good, but you will not understand anything, right, because it is too complex tree. And decision tree has a very main drawback, that is overfitting. It tries to create a decision tree for the training data variable. So, it performs very good on the training data, 100% accurate, but on a test data it is not known to perform well, just because in a training data it takes all the small conditions, it tries to create a new branch for fix that condition, but in test data it is not possible. So, that is a bigger problem. And the greedy search algorithm I mentioned in the starting of this video, there is a greedy search tree. It means only local decision mode might lead to the nest decision. It is not possible. Sometimes you have to combine decision of 2-3 features to make a good decision, but that is not possible in decision tree. Also, it is not applicable for continuous data. You have to make decision splits before you start decision tree, but latest algorithms automatically makes bins based on the probability of each bin. So, that is not an issue. So, I said there are 2 problems, right, there is complexity and pruning. So, complexity and overfitting, that can be solved by pruning. What is pruning? It is basically cutting out the branches, trimming the tree, right. You have to, your tree is very dense, too big and too dense, so you have to cut down the branches. So, make it trim so the tree can grow further and looks good. Exactly that is what happening in the decision tree also. Here what they do is they cut down the branches, which makes not much decision, then they cut down the branches to reduce the complexity. Also cutting down such kind of pruning helps in better performance. So, in the sense it helps in improve the performance of the decision tree in the test data set also. Okay. That are the 2 advantages disadvantages, but that can be solved by the pruning methods, and other disorders also can be taken care by the latest machine learning algorithms. So, it is not an issue. So, in this video we saw what is decision tree learning, and I request you to go and try decision tree in tools and check it out. I did not give a complex problem for decision tree, but I would request you to practice decision tree using the complex set of problems with more features, more decisions to make, and see how it works. Thank you.